In lesson 5.6, you will find rational zeros of a polynomial function. In our first example, we're going to find all rational zeros of f. F is a cubic function, and to find its zeros, we want to factor and use the zero product property. We would want to try and factor this polynomial in 4 terms using grouping, but since grouping won't work on this polynomial, we need another method. We need to look at possible zeros, or p over q. Now p in the top of this fraction are all factors of our constant term 30. So listing those factors, we have plus or minus 1. 2 goes into 30, so plus or minus 2. 3 goes into 30, plus or minus 3. 4 doesn't, but 5 does, plus or minus 5. And 5 goes into 36 times, so plus or minus 6. 3 goes into 30 10 times, plus or minus 10. 2 goes into 30 15 times, so plus or minus 15, and 1 goes into 30 30 times, plus or minus 30. So there's our complete list. And in the denominator, our q values are factors of our leading coefficient. Now our leading coefficient is just 1, so plus or minus 1 are the only factors we have to consider. So this is nice because all we have is those integers in the top over plus or minus 1, which means all we have are the integers in the top to consider. Now to find our first zero, we want to use synthetic division, and I'm going to start at the beginning of my list, and I'm going to choose to synthetically divide 1 through the coefficients of my function. Now the coefficients are 1, negative 4, negative 11, and 30. Remember, every degree has to be represented, so I'll check. It's third degree, 3, 2, 1, 0. Every degree is there. So I'll put down a 0, and I'll add that first column and get 1. Multiply, 1 times 1 is 1. Add the second column, get negative 3. Multiply, 1 times negative 3 is negative 3. I'll add again, total of negatives, negative 14, and then multiply. 1 times negative 14 is negative 14. But I can see when I add this last column, I'm not getting a remainder of 0, and that's what I'm looking for. So I'll try my next value in my list, which is negative 1, and I'll divide it through the coefficients of f. Synthetically, I'll put down a 0, and I'll add that first column, and then I'll multiply. Negative 1 times 1 is negative 1. I'll add, get negative 5, and then I'll multiply. Negative 1 times negative 5 is positive 5. I'll add this column, get negative 6, and multiply. Negative 1 times negative 6 is 6. And when I add this last column, again, I'm not getting a remainder of 0, and that's what I'm looking for. So I'll try 2 through the coefficients. I'll put down a 0 and add. Multiply, 2 times 1, add. Multiply, get negative 4, and I'll add. I get a total of negative 15. And now when I multiply 2 times negative 15, I get negative 30, and when I add, I get my remainder of 0. So I've found the first zero of this function. It is 2, so I can start factoring f. So f of x is going to factor into x minus that 0, x minus 2, times the quotient that I get at the bottom of the synthetic division. Remember, these are the coefficients, and the first term is 1 degree less than the polynomial I divided into, so it's 1x squared minus 2x minus 15. Okay, and now I want to completely factor this function, let f of x or y equal 0. So I want to factor that trinomial, and hopefully it'll factor into a binomial times a binomial. Factors of x squared are x times x. Factors of 15 that have a difference of 2 are 5 and 3. I'll make the 5 negative and the 3 positive, so that positive 3x and negative 5x are negative 2x in the middle, and positive 3 times negative 5 is negative 15. So that function is completely factored, and now I can use the zero product property to find my zeros or x-intercepts. So solving for x, I have x equals 2, but we know that because we found 2 synthetically. X equals negative 3 or x equals positive 5. Those are the three zeros or x-intercepts of this cubic function, this third degree function. Okay, let's try that again. Let's find all real zeros of f. And because this is a quartic and has 5 terms, there's no method other than our possible rational zeros to start factoring this function. So factors of p are factors of our constant term, 12. So I'll list all of those, plus or minus 1, plus or minus 2, 3 goes into 12, and 3 goes into 12 4 times, so plus or minus 4. 2 goes into 12 6 times, and 1 goes into 12 12 times. So those are all the factors of 12. Now in the denominator, q is factors of our leading coefficient, which is 9. So plus or minus 1, 3 is a factor of 9, and 9 is a factor of 9. So those are our possibilities. Now all of our possibilities are the integers in the top over the integers in the bottom. So we could be looking at some fractions here as possible rational zeros also. So we want to find that first 0. So we're going to use synthetic division, and our coefficients of our quartic are 9, 3, negative 30, 6, and 12. Every degree is represented 4, 3, 2, 1, 0. So we're ready to divide synthetically. So I'll add this first column and multiply 1 times 9. I'll add and get 12 and multiply 1 times 12. I'll add here and get negative 18 and multiply, get negative 18. And when I add, I get negative 12. And when I multiply 1 times negative 12, I get negative 12, and adding, I get 0. So I got a remainder of 0 already, which means I found the first 0 of this function. I'll start factoring f. F of x is equal to x minus that 0 of 1 times what quotient? 9x cubed plus 12x squared minus 18x minus 12. Okay, now I need to continue factoring this polynomial of the third degree, and grouping is not going to work. I can try grouping, but those binomials that I'll factor out of groups of terms here are not going to be the same. So we have to continue with possible rational zeros, and since my constant term is still 12 and my leading coefficient is still 9, I'm looking at that same list of possible zeros. So I'm going to continue in that list. I'll start with negative 1. I'll continue through the list and look at negative 1 through the coefficients that I have left now. 9, 12, negative 18, and negative 12. I'm trying to factor that cubic. Put down a 0, and I'll add. I'll multiply. Negative 1 times 9 is negative 9. I'll add and multiply. Negative 1 times 3 is negative 3. I'll add and get negative 21, and multiply and get positive 21. And I can see when I add, I'm not going to get a remainder of 0. So now I'm going to try 2 through those coefficients of 9, 12, negative 18, and negative 12. So put down that 0 and add, multiply, add, multiply, add, let's see, subtracting, looks like 42, and multiply. I'm going to get 84, and I'm not going to get a remainder of 0. So I'll try negative 2 now through those coefficients. 9, 12, negative 18, and negative 12. Put down a 0 and add. Negative 2 times 9 is negative 18. When I add, I get negative 6. Negative 2 times negative 6 is positive 12. When I add, I get negative 6, and multiply. Negative 2 times negative 6 is positive 12. So here's my 0. I just found another 0 of this function, so I'll continue to factor. I've got x minus 1 now times x minus that 0 of negative 2. That's double negative, so I'll write this factor as x plus 2. And the quotient that I got is 9x squared minus 6x minus 6. Okay, I need to continue to factor this quadratic if I can. There's a greatest common factor of 3, so I'm going to pull that factor of 3 out front from that trinomial. So I'm going to be left with 3x squared minus 2x minus 2. Okay, and now I want to try and factor that trinomial into a binomial times a binomial. So I'd factor 3x squared into 3x times x, and 2 into 2 times 1. Those are my only possibilities. But if I put 1 here and 2 here, I can't add 1x to 6x to get 2x in the middle. And if I switch them and put the 2 here and 1 here, I can't add 2x to 3x to get 2x in the middle. So that quadratic is not going to be factorable. This polynomial f is completely factored now, and I want to let f of x or y equal 0 and use the zero product property from here to find all my real zeros. So I'll let x minus 1 equal 0, or x plus 2 equals 0, or that trinomial 3x squared minus 2x minus 2 equals 0. Okay, so solving for x, I'm going to find that x is equal to 1, or x is equal to negative 2, or here I'm going to have to use the quadratic formula to solve for x since it didn't factor. So using the quadratic formula down here on that trinomial, I'm going to find x is equal to negative b, and b is negative 2, so that's double negatives, plus or minus the square root of b, so that's negative 2 squared, which is 4, minus 4 times a, which is 3, times c, which is negative 2, all over 2a, and a was 3, so 2 times a is 6. Okay, simplifying underneath that radical, I'm going to have 4, and negative 4 times 3 is negative 12 times negative 2, that's positive 24, over 6. So I have 2 plus or minus the square root of 28, which is going to simplify, over 6. The perfect square factor in 28 is 4, so the square root of 4 is going to give me 2, and I'll have the square root of 7 left, over 6. And now there's an extra factor of 2 in every term in this fraction that I'll get rid of. So I'll have 1 plus or minus the square root of 7 over 3 as a simplified factor or 0. And so I can list those separately. I'll have 1 minus the square root of 7 over 3 and 1 plus the square root of 7 over 3 as real zeros. I have 2 rational real zeros and I have 2 irrational real zeros for this function of the 4th degree. Include with your notes of this video guided practice problems 2 through 6 even, found on pages 371 and 373 of your textbook.